Hi, thanks for coming. My name is Sid Rao. I'm the general manager of the Amazon Chime SDK. Today we'll be talking about how to use multiple APIs and primitives from AWS to improve multi-channel communications and a number of different use cases and workloads for customers in terms of how they leverage these primitives to basically enable their apps, add communication capabilities to their apps, whether that's an email, a text message, a voice or video session, and also how to coordinate these sessions together to create customized customer experiences to improve customer service, improve user engagement, improve the sales process and other workflows within their business. So customer service tools, there's a number of different ways to look at the problem set, but customer engagement is a crucial aspect of how to grow a business and how to improve the customer experience and how to basically ensure that customers get what they're expecting on their terms in the channel that they're expecting to use those services. So from a perspective of Amazon, when we look at this problem, we look at it as a leadership principle around customer obsession. We're always looking to try to improve the customer experience, especially in our retail segment of our operation. And those learnings that we have built from the retail side have now been basically surfaced as primitives or APIs for customers to use within AWS. And I've basically been in the communications industry now for about 20 years and been doing this for quite a lengthy period of time. And I've watched as we've evolved our communication platforms within our retail organization and basically brought those services and capabilities within AWS, surfaced as services such as SES, Pinpoint, or the Amazon Chime SDK. So in terms of what customers are looking for in terms of a communication session, look, the ability to send an email or send a text message or place an outbound phone call in an automated fashion from a platform is not a new construct. These services have been around for decades. They're mission-critical services that almost every enterprise customer or independent software vendor requires for their business to be successful. The key crucial difference, though, is that customers have an expectation that these communication sessions are engaging, they're useful, they're customized to the content or the reason why they're engaging with a particular organization. And when these types of sessions are customized and made engaging, we have organizations like Accenture that tell us that about 75% of such customers are very likely to continue to purchase and recommend an organization that creates these types of engaging sessions. So it's no longer about just being able to send an email or be able to send a text message or place a call. It's about basically using data that's stored within a VPC, for example, using machine learning and securely accessing these services to create an engaging customer experience. When you do engage with a customer, the expectation is that it is now an omnichannel experience. It's no longer appropriate just to basically engage on a voice session or on a video session or on an SMS session without providing continuity across both asynchronous and synchronous forms of engaging with that customer. So, for example, let's just go through a simple use case of a fraud notification from a bank. The typical thing that you would see is a text message that gets sent to the customer's cell phone, but when they want to now engage with that fraud workflow, they may want to engage in the form of a phone call, they may want to be able to asynchronously just respond via text, they may want to use email, for example, to verify that fraud transaction or to dispute that fraud transaction. And when they use these different channels, they expect coordination and they expect personalization across these channels. So when you call into, for example, a contact center that's associated with that fraud session, they expect that text message notification to be coordinated with what the agent is talking about from a contact center perspective. It's no longer acceptable for many users to basically start over or re-authenticate themselves through these different channels of how they're trying to resolve a situation like a fraud use case. So when you look at the broad-based industry surveys out there, you'll see a pretty common request from users of these types of services that 9 out of 10 of them require an omni-channel experience with some level of continuity between the voice channel, the text channel, or the email channel that's being used to engage them as a customer. And when it comes to actually achieving this promise, though, unfortunately, as an industry, we're basically, we're still not able to do this in a very consistent way. But only, industry surveys show that only about 2 out of 10 or 3 out of 10 customers feel like they're receiving these types of engaging customer sessions and have an engaging customer service experience. One of the reasons why we see this is because if you look at a traditional enterprise customer, they tend to have disjointed islands of ways of engaging with customers. So we often see with enterprise customers that some of these customers may have a contact center platform that's different than, say, an outbound marketing campaign platform, which is different than what they're using, for example, with social media. And they don't have coordination or continuity across these different services. And further, when we talk to enterprise customers, we unfortunately find that they're not using the data that's available to them, both at least for simple problems like even just coordination of how did we reach a customer and are we talking to the customer about the right topic. But even for more advanced topics like machine learning, they're just out of reach for many customers, typically because they have kind of these islands of disparate communication tech, and they've not been able to coordinate them or integrate them across multiple different services that they've deployed. And the business impact of this is pretty profound. 1 out of 3 customers basically end relationships because of poor customer engagement, poor customer service, or not having an intelligent communication channel with an organization, whether that's for purchasing goods, getting support on a contract, or basically inquiring or trying to get questions answered about a particular product or service that they're purchasing from an organization. So what are the challenges? As I basically described, first of all, we have these disparate islands of different platforms that are in play. We're going to go through a couple customer examples and specifically talk about the APIs and services they're using from AWS in this presentation today. But typically what you find is that there's, first of all, a lot of risk aversion around communications. It's a utility that many times is ignored actually within an enterprise IT planning process, but it's also a super critical workload. When it goes down, it's a profound business-stopping type of event from a communication platform perspective. So there's a tremendous amount of risk aversion in the industry about how to handle these communication services, how to basically modernize them, while at the same time, ensuring a high degree of availability, resiliency, global access, and various related topics related to resiliency and operational readiness. From a perspective of risk, there's also another aspect that causes pause in this kind of communication services area, which is there's a number of old guard communication providers providing platforms that come with risky and expensive capital licenses, operational expense, and it's difficult to transform or change the economics of the communication services that the company is using. So, for example, if you look at the banking customer that I was just describing a couple slides ago, in their case, they have kind of an old guard telephony system running their branch office communications with traditional desk phones and hard phones. They pay capital licenses and expensive maintenance fee contracts on that telephony platform. They have a separate platform for recording and analyzing the sessions that are occurring in those branch offices. And in that particular case, they're paying, again, more capital licenses associated with like a recording and analytics platform. Then for customer notification channels, they basically have gone off and purchased a text messaging notification service for sending these fraud notifications, related actually to an adjacent purchase they made in the one-time passcode arena. And so they have multiple different platforms, high capital fees, high operational fees, usually specialized knowledge required to manage these platforms. So in the case, unfortunately, of this banking customer, they had 2 people in the entire organization who knew how to upgrade that telephony platform and how to upgrade that communications experience for their branch office and banking use case. So tremendous amount of risk in terms of coordinating across the organization, finding these specialized skill sets, and then from an impact perspective, obviously if they cause issues to, say, the telephony platform or the text notification platform or the one-time passcode platform that they have, it's a business-breaking problem for them. So there's a high degree of availability concern combined with kind of a risk aversion, combined with the specialized skill set requirement, along with the capital licenses and operational expense that comes with these communication services and platforms. So as a result of that, it's difficult to modernize or upgrade these platforms. And it creates a little bit of inertia, organizational inertia, around moving these platforms to the cloud. And often, from an AWS perspective, when we talk to all-in customers, we find that communication services are kind of the last rack that's sitting within their data center. They're the last rack that can be moved to the cloud. It's often one of the more complex racks that customers have to manipulate or manage. Then when it comes to the actual, in terms of resources and scaling, that you have your own set of challenges that come from a perspective of like scaling. Auto scaling is actually, in many of these organizations that we work with, is actually a foreign construct for their communication sessions. Oftentimes, we have customers who are purchasing proprietary networks via MPLS to provide the communication services to their organization. They're buying, fixed kind of capacity compute infrastructure for, if you go back to that phone call example, for things like session border controllers or, proprietary voice firewalls to provide the transit capability for voice sessions. In the video world, there's fixed, capital-intensive licenses and equipment for doing the video conferencing or video capabilities associated with their customer engagement platform. And so you have a tremendous amount of fixed proprietary licenses that don't scale, and then you run into challenges around seasonality, the ability to automatically scale when there is an event or a problem. And as a result of that, the organization kind of gets limited. It reduces the agility of the organization, and all the benefits of the cloud aren't necessarily applicable to this super critical workload called communications. So a great example of that is the United States Postal Service. So the United States Postal Service was asked by the White House to basically scale up and send out, literally, 500 million test kits within 21 days to the United States, to various United States citizens. The CIO of the United States Postal Service basically described this as one of the hardest things that he had to do within his career. It was unprecedented in terms of scale, size, scope, and the technology that was required to get these test kits put out. And let's take a moment and understand how this would have historically been handled. So when I first joined Amazon as a software development manager at Amazon, one of the services I owned was something called a mail relay. And it was a fleet of literally EC2 instances that did nothing but basically act as a transit center for sending and receiving email. Simple service, but super critical service, obviously. So every time you went to Amazon.com and purchased something on Amazon and you got a little notification saying thank you for your purchase, that went through this microservice called the mail relay service. And it would go down sometimes because, basically you would have, spam situations or storms of emails that would have to get out. Peak and seasonality would impact it. And so coming back to the US Postal Service, historically what they would have done to solve this COVID test kit email notification problem is basically scale up their mail relay fleet. But if they had chosen that approach, there's a couple different drawbacks to that. First of all, they would have kind of this infrastructure and fleet they would have to now manage for sending and receiving email. They'd be responsible for the reputational risks of sending out these emails, being categorized as spam, managing everything from MX records to deliverability to how you work with the various different ISPs from a spam and reputation perspective. And basically, they would be also responsible for all the aspects of making sure that confirmation email gets out the door. So integration with the software stack to send and receive the email, bounce notifications, all of the related problems that come about with email. So the US Postal Service took a different approach. And in retrospect, this seems pretty straightforward, but for a lot of enterprise organizations, deprecating that old exchange mail relay infrastructure that they had is actually a pretty big step. Because again, if this goes down, it's pretty much game over for the US Postal Service in terms of making sure that that entire workflow of a COVID test kit is achieved for the citizen. So SES and the Accenture team basically worked with the US Postal Service to create this mail confirmation order workflow. 20 million order workflows were sent per hour at launch. On January 19th, we launched the service with the US Postal Service. Millions of test kits get delivered. And we have a very happy citizen and a very happy US Postal Service. And then, of course, since it was a completely serverless-based architecture, the entire service was able to be scaled down. And it was a pay-as-you-go, pay-for-what-you-use type of solution. And effectively, US Postal Service was able to delegate things like ISP and reputational risk, ensuring deliverability of these order confirmations to SES, and not have to worry about these problems within their own infrastructure. So SES is actually one service out of 3 in a category called AWS Communication Developer Services. So Communication Developer Services basically powers a number of different workloads. So these workloads span everything from simple messaging services, so SMS and text notifications, in-app notifications via, for example, Apple push notification services, APNS, SES, programmable voice and video. So for example, the Amazon Chime SDK powers the ability to do outbound call notifications, lightweight IVRs, integrations with Lex, for example, for being able to do conversational AI related to these telephony platforms. Of course, video-based services, for example, with WebRTC, for everything from multi-party audio-video sessions to one-to-one video consultations that customers require. And in terms of the scale that these services operate at, we're talking about billions of audio sessions and video sessions for customers like a Slack with, for example, Slack huddles, to over 10 billion SMS messages sent globally through Pinpoint and also through the simple notification service. In-app notifications to mobile app users sent through Pinpoint as well. And of course, SES has been routinely sending out hundreds of thousands of emails per second globally across multiple regional endpoints for use cases as we just described for the US Postal Service. So these services are routinely used at scale in very, very, very large workloads, like, for example, Slack huddles, but also down to point or point solutions, for example, for campaign management or personalized notifications using machine learning. So very broad use cases to also very narrow point type solutions where customers need help. So in terms of the customer list, typically Communication Developer Services was targeted around the independent software vendor type of community. So We just described Slack, for example, with Slack huddles. That's very much what we would call an independent software vendor style application, where you had a software application like Slack. They wanted to add multi-party audio video sessions to it, create this virtual audio space. They needed to be able to power this with a WebRTC-based service that works within browsers and mobile apps. And they basically integrated huddles into the core aspect of their product and their value proposition. But we've recently now started to serve actual enterprise use cases as well. So, for example, servicing in a banking environment, video mortgage services or video lending services is actually a pretty typical use case that we now have to support. If you look at unemployment benefits, doing weekly unemployment counseling for large governmental services, again, over video in a FedRAMP moderate or FedRAMP high type of environment for ensuring regulatory compliance. Telemedicine use cases with hospitals. So Beth Israel, for example, with the Harvard medical community, went and implemented their own custom telemedicine story that is very much built to the requirements that the Harvard health system required. And they were, we're very thankful for them for writing about exactly how they built a customized telemedicine platform to meet their particular requirements. So we now span from independent software vendor applications, so in the case of Pinpoint, push notifications to a mobile app, very common ISV requirement, now broadening into more of the enterprise use cases, whether that's around things like video contact center, IVR services that integrate with databases that are stored on the VPC, to contact center applications where they're extending an existing platform, such as a Cisco Unified Communication Service, or for example, a Genesys or a Avaya-based platform from a perspective of contact center enhancement and augmentation. So when we think about communication developer services is a category, and we tend to focus more on the workloads that we power, whether those workloads are, as I described, like an interactive voice response or agent assistance use case. And customers use the APIs we provide at multiple different layers. So from a layering perspective, what are the layers we provide? We obviously provide a very core routing layer. And what exists in this routing layer is, for example, with SMS, is the ability to globally integrate with SMS wholesalers, ensure deliverability of text messages, and be able to deliver them across multiple different telco networks across the globe. So this is all about availability, high quality of deliverability, ensuring it can route around certain communication provider failures that happen in a pretty disjointed and complex network like SMS, to also ensuring that we're able to provide feedback back to the customer about was that message able to be delivered. And the same problems exist also with email, with the ability to do voice sessions, with phone calls, or of course browser-based calling with WebRTC. So there's a core routing layer. So what exists at that routing layer in the world of SMS? The simple send message API that you see, for example, within Pinpoint would be in that routing layer. We then provide basically a layer above that, which is focused around identity. This is around phone numbers, short codes or long codes in the text messaging world, email domains, and the DNS infrastructure required for email and deliverability and DMARC records and things of that nature in the email world. Phone numbers, porting of phone numbers, that whole identity and business identity problem is the next layer of the communication stack, where we again have APIs in the AWS SDK, SIG-v4 authenticated APIs that allow you to procure, provision, transfer, and port these identities from alternative service providers into AWS. Then there's a layer that is around the actual core APIs related to the protocols involved. So in the world of telephony, for example, SIP endpoints that are session initiation protocol endpoints that allow a customer to integrate their existing platforms with AWS services. So what are the use cases there? So thinking about the interactive voice response use case, customer wants to dial into an existing telephone number that's owned by a large banking customer. They do not want that phone number to be migrated to AWS, but they want to use AWS services. Well, so the call hits the actual phone number that the customer owns. They then use session initiation protocol SIP APIs that are available from AWS to route that session into their VPC. We then provide a Lambda-based API for handling that call, performing treatments. So for example, playing an announcement with Polly, saying thank you for calling Sid Rao's bank. And then being able to transfer control of that call to, for example, Amazon Lex. So a conversational experience can occur, such as, please pay Sid $1 trillion, or maybe I need to deposit my Wheel of Fortune winnings from today into my bank account. And basically, I'm able to do that through a conversational experience with Amazon Lex. The intent is then captured with Lex, and maybe the decision is to route the call to a far-end branch. And so that intent is then sent back to a Lambda controller, which then is basically able to route the call again via SIP to a far-end branch. So we provide communication APIs that are customized for the channel. So in the case of telephony, it's SIP. In the case of WebRTC, it is a set of browser RESTful APIs with the JavaScript and mobile and Android iOS and Android SDK. In the world of SMS, it's text messaging via APIs that are modeled for the world of text messaging, so short code, long code, sandboxing, all the typical deliverability APIs and feedback APIs you require. And the same analogy also exists within the world of SES. So communication APIs that are modeled to the communication channel that you're trying to engage, whether that's telephony to SMS. And then finally, we provide a value-added layer on top of that for common workloads. So for example, a common workload is one-time passcode. We all have OTP needs where you want to send a notification as part of a password reset to a mobile phone, or maybe it's a text message notification for confirmation or authentication or identity. And so in that world, Pinpoint provides a value-added API that makes it, within about three lines of code, I can basically add OTP to my password, my password form, for example, on my website. So for common workloads, we've then created, value-added APIs that streamline that process, make it very simple for a developer to add that capability to their website. Now, in some scenarios, we actually provide core managed APIs like OTP. In other scenarios, we have AWS solutions where where we've created kind of prepackaged, components that a customer can easily use to snap in a capability into their website or to their platform. One of those solutions is actually live call analytics. So what is the live call analytics solution? Well, let's talk about T-Mobile. So T-Mobile has a pretty large contact center. It's about 60,000 agents. They use a Cisco Unified Communications Manager as their core call control platform. They have a Unified Contact Center as their actual contact center service. But T-Mobile wanted to improve and optimize the way that agents were handling calls. So they wanted to be able to provide live coaching, machine learning-based insights that enable an agent to basically automate the call handling, reducing handle time, making it a more efficient and, again, engaging experience from a perspective of handling inbound calls. Classic example, you call into T-Mobile saying, I dropped my phone in the swimming pool, it's no longer working. The agent gets pre-canned advice that's machine learning based as to how to handle that call, how to handle the swimming pool problem, how to replace the customer's iPhone. So what did T-Mobile do? So T-Mobile basically integrated using, a session initiation protocol API. It's called SIPREC, an ability to take audio from their existing unified their unified contact center environment that is on premises, take a copy of that audio, feed it to SageMaker for for gathering that machine learning insight. They also use transcription services on AWS to basically transcribe that content. They're able to determine the sentiment of the caller, determine the actual content of what's being actually said on the call, and then they basically search, again, using a machine learning algorithm, and knowledge base to figure out related content to help that customer in an automated way. And then they send screen pop notifications to the agent's existing desktop, which is based on Cisco Finesse, to effectively coach or automate the call handling for their customers. The net result was an 18% reduction in handle time for T-Mobile. So tremendous amount of kind of productivity enhancing results for their agents. And they also improved the engagement or the happiness of the customer when they were calling in. So pretty sizable business benefits for T-Mobile as to how they were able to achieve their particular productivity goals. So why did T-Mobile, for example, use AWS in that particular use case? There's a couple different reasons for that. One is they wanted all the resources to be available within their virtual private cloud. They didn't want this customer data, such as the transcription or the actual machine learning models, to be outside of the security boundary of AWS. It allowed them to basically standardize their infrastructure and standardize the APIs that they were using to integrate with AWS. And then from a perspective of global access, deliverability, the fact that they were able to do this in a geographically redundant fashion across multiple regions because of the multi-region capabilities of our APIs, they were basically able to standardize and simplify a new feature, agent assistance, and by the way, make it work across multiple different platforms. So in their world, they have multiple different contact centers that they're trying to integrate with, and while this is now a feature in one specific contact center, they wanted to be able to standardize the implementation across multiple different contact center platforms that they've actually acquired, especially after the acquisition of Sprint. So global access, standardized API, they were able to create one single microservice for this whole agent assistance use case and the machine learning capabilities that they built related to it. And they were also able to leverage all the security boundaries and capabilities, everything from PCI compliance to some of the SOC requirements they had to basically handle this sensitive customer data. So another example of this is Bundesliga. Bundesliga basically is a fan engagement platform. We actually do fan engagement with a number of different types of customers, and the typical problem here is they want to be able to send customized notifications to fans, personalizing the content, usually using personalized or recommendation engines that they're using within AWS to send customized content to the customer about what they believe the customer would be most interested in hearing or understanding from AWS. So in the case of Bundesliga, they had a new application. About 500,000 users were using this app. They're a football organization, so they wanted to be able to send out, for example, clips or related content that would help their, basically engage their fans or delight their fans and ensure their fans continue to use their mobile app and continue to be engaged with this football team. So in this case, they use Pinpoint with personalized, Pinpoint for the notification channel. Pinpoint provides a Lambda hook, basically, for deciding what messages are sent to what segments and what portions of the population. Personalized, basically, is used as a recommendation engine in terms of what content would be most relevant to a specific segment or section of their user base. And that segmentation mechanism ensures that the right content, the right recommendations, and the right insights are delivered to the users on the channel that the customer wants to receive it. In the case of Bundesliga, they focused more on the kind of the Apple push notification or Google notification mechanism to engage their customers, but we have other customers who are doing this across multiple different channels. In fact, again, going back to financial services, in those cases, there often will be sending a campaign notification via mobile push that's coordinated with SMS and may even be result in an automated follow-up or call from a local branch. So, again, multiple different options as to where in the stack you want to integrate. You can, in this case, they're integrating at a pretty low level, which is the mobile push notification channel that we provide, but also using some of our campaigns and segmenting capabilities that are in Pinpoint. while also using our machine learning services in conjunction with this for recommendation. But we have customers who are using, again, those higher order APIs for things like one-time passcode, where it's less complex, but it's a very simple use case. So in terms of, what are the three core requirements of, what are the three kind of driving tenets of communication developer services is, first of all, this intelligence aspect, as we've probably noted across these two customer examples, intelligence and machine learning is perhaps one of the most important aspects of what a customer is doing today with communication services that come from AWS. So it's not good enough just to provide a low-level API for sending and receiving text messages. No, what AWS does is provide additional capabilities, whether those are programmable hooks with like Lambda hooks for notifications of events that occur across these communication channels, but also pre-canned integrations with existing AWS machine learning services. So coming back to that phone example, the ability to automatically just pass control to Lex with a simple Lambda directive, or play back an announcement with Polly. So that intelligence aspect of integrating just kind of seamless, direct integration with those machine learning services is a crucial customer ask, and we do fulfill that ask through these integrations with AWS ML services. A second requirement is the ubiquity aspect, right? So the ability to provide access across the devices in terms of how a customer wants to access these particular services. So broad set of device and compatibility and interoperability. We work with everything from a existing on-premises SIP-based platform or session initiation protocol-based platform, all the way to global access to dozens and dozens of countries from a public telephone network service capability, all the way to, as we'll describe later on in this presentation, working with Alexa devices or Echo devices. So broad accessibility across the devices that a customer wants to use to communicate with an organization. And finally, we come to that reliability aspect. So looking at, for example, the Amazon Chime SDK, we provide voice and video services for WebRTC across 18 different services globally. So being able to provide basically multiple accesses across all of our global, providing global access basically to our services across multiple different regions and providing automatic redundancy across these particular regional deployments that we make. So in terms of the actual journeys and campaigns and things of that nature, when it comes to the intelligence aspect, if you look at Pinpoint, for example, it provides that campaign management and segmentation by using machine learning as well. So you're able to, for example, create a campaign for follow-up that's based upon the sentiment of the caller as to how they were calling into your contact center. So you're able to create these very personalized, well-structured, and focused communication mechanisms by using our campaigns and journey and segment capabilities. And again, that's a higher order service that we provide for customized and targeted messaging of those text messages or push notifications. In terms of the ubiquity aspect, coming back to the voice assistant problem, for example, one of the questions is like, why would Amazon support Alexa, for example, as a calling endpoint into a contact center? Well, Alexa is very popular actually with certain generational segments, for example, where it's just more convenient for them to talk to an Echo than it is to pick up the phone and call somebody. A classic example of that is if you're staying at the Wynn next door, they've put an Echo in every room. Well, you can imagine as part of that particular process being able to drive things like calling the concierge or calling room service or calling certain actual endpoints within that particular hotel. So again, it's about ensuring the customer can engage with the organization using the device that they're most comfortable with. So we're working with a banking customer, again, who wants to send credit card fraud notifications to Alexa devices just to make it easier for a customer to reach out and touch that bank when those types of events happen. Yes, they can do this with the phone. Yes, they can do this with browser push notifications. But what they've found is when they send that across multiple different devices, and when the customer has an option or a choice as to how they can engage with that bank, they have a higher probability of reaching that customer, ensuring that fraud is mitigated and risk is mitigated in that banking or financial services use case. So at reInvent this year, we launched the ability for Alexa Skills to reach organizations using an Echo or Alexa-powered device. So classic example of that is Alexa, ask my insurance skill to call my agent, for example. And it'll just initiate basically a call directly to the agent, directly from your Echo. No phone numbers to write down, no callbacks to initiate, no signups or authentication flows, nothing of that sort. It's just a simple ability to engage an organization directly using the Echo device that is sitting in your kitchen. And how are customers using this? They're using this for outbound marketing aspects, inbound notifications that result in closed loop callbacks, a number of different ways of basically providing an endpoint to deliver a call to the customer without requiring a separate step like pulling out your phone and dialing a number or requiring a call back or anything of that sort. So again, from an accessibility perspective, this service is available via SIP. It works with whatever platform that you may already have deployed within your organization. We're not requiring customers to modify their existing contact center platform or existing communication platform to add this capability to their service. And that's a pretty common requirement that our customers have, which is if I want to add agent assistance or add Alexa calling, for example, to my contact center, I don't want to have to go through a lengthy, expensive upgrade process or go through agent retraining or any of those associated problems. I just want to add the feature to my existing organization. So again, in terms of how it works, it's a pretty straightforward implementation. The skill implementation is still the same Lambda-based invocation that you have today for skills. We just basically added a new API within a skill to say start communication session. You can provide in that start communication session function a blob that provides context about why that customer is calling into that contact center. And that context part is pretty important for our customers. And so what would be in this context? Well, if the customer has been kind enough to sign into their skill, authentication information or user profile information can be passed along to the far end contact center, therefore eliminating the need to authenticate a user. Great example of this is in telemedicine, being able to directly call, for example, a care team, and the care team immediately knows who the patient is. There's no need to do an authentication step or verify dates of birth or medical record numbers. So that identity information can be passed along. Secondarily, information about what the customer was asking about before they engaged or created that call is also pretty useful. So the dialogue that occurred with the Alexa device before the call was initiated, that the entire dialogue can be passed along to the far end contact center or to the far end phone system. So that's a second aspect that's provided in that context. And so when we do provide access to these new devices like Echoes or browsers or mobile apps, we're able to add a level of intelligence or associated context that you just don't get with traditional phone calls or SMS, and we're able to enrich the customer experience because we have access to that additional data. And all that does is basically speed up the handling process or the service process. And probably one of the most frustrating things we do every day is have to call our local hospital, for example, and re-authenticate ourselves 5 times before we finally get to the care team. Well, those problems go away when you're able to create these kinds of intelligent device stories around things like Echoes or browser-based calling, because you can basically say, I know why the person's calling, I know who they are based on how they've signed into the platform, and I know what led them to the phone call, and all of that information can be passed along to either the automated chatbot that's handling the call or the human being that's handling the call to speed up the process and make it a more engaging and useful customer experience. So again, this is implemented with 2 Lambdas. There's a Lambda for the skill, there's a Lambda for the actual call processing aspect or sending the outbound call to the far end contact center. Pretty simple implementation, all automatable via CDK with a CI/CD deployment mechanism. The solution's on GitHub, happy to share with folks after the session. So pretty straightforward, standard cloud-based deployment model. By the way, coming back to that skill set requirement that we were describing before, the skill sets required to create this communications capability is TypeScript, Node, Lambda. You don't need to know anything about SIP. You don't need to know anything about telephony. You don't need to know anything about how Alexa devices even work. Really, you just have to have familiarity with basically writing lambdas in the programming language of your choice. And anything that's available to you in a VPC, whether it's a RDS database with database information or APIs to Epic if you're building a telemedicine use case. That's all those APIs are also securely available to you when you're building these applications, including the machine learning services we described today, whether that's personalize, transcribe, comprehend, Poly, or Lex. So there's a convenience aspect, even from a developer perspective here, of we've eliminated all the complexity that's associated with sending and receiving these communication sessions. So, in terms of reliability, we described our country and global coverage already in terms of how we're deployed. We also have FedRAMP moderate and FedRAMP high deployments today in GovCloud for our governmental customers. That's something that's often forgotten about. So it's not just a global coverage perspective from a perspective of countries and, like, for example, the 18 regions we provide audio and video services with today. It's also about GovCloud, data sovereignty, providing data sovereignty solutions, for example, for European customers. So we're able to provide our global services aren't just about reliability, it's also about providing these data sovereignty, and compliance and regulatory requirements as well. One thing to keep in mind, though, about the communication services we provide is that unlike a traditional AWS service, which it tends to be deployed within a region or kind of focused on a region, we provide automatic regional failover and the ability to leverage multiple regions simultaneously. So we decouple control and data plane for many of these services and allow you to basically fail over audio and video sessions across multiple regions for redundancy and reliability perspectives, reliability requirements. So coming back to kind of that reliability and deliverability and availability problem, Simple Email Services also launched some features at re:Invent that we feel will be quite useful for our customers. And this is really focused around the deliverability problem and reputation aspect of email. This is something that tends to be overlooked by folks who are trying to build email microservices. When an app is being built or when they first get started, it's sometimes easy just to use the mail relay services that are available to you or use the email services that might be in your organization, whether that's Exchange or an SMTP endpoint that's homegrown within the org. And then as you scale it out, you start to run into more and more problems, whether those are spam problems, deliverability problems, figuring out why that email isn't making it to a customer, where is it getting lost in the mail delivery chain, and figuring out where the problems are, getting insights on what's stopping your message from reaching your customer, and getting automated insights that basically help you figure out how to improve your mail deliverability story. So SES launched basically a series of automated insights, almost like a guardian program, basically to ensure that customers understand why are emails not making it to customer inboxes, what's happening from a tracking and delivery perspective, and how can we ensure a higher degree of availability from a deliverability perspective for these important notes. So coming back to kind of that order confirmation use case, for example, for the United States Postal Service, it would have been a terrible customer experience if COVID test kit order confirmations were going out and people weren't receiving them. They would have gotten flooded with a whole bunch of contact center calls going, where's my test kit? So being able to delegate that problem to Simple Email Service and letting SES handle the deliverability problem saves organizations like it allows organizations like the United States Postal Service to focus on their app and not have to worry about delivering emails to folks via SMTP. So while it might seem pretty straightforward and pretty clear as to why you would use a service like SES, we still find a lot of enterprise organizations that are still trying to maintain their own mail relay fleets, their own exchange fleets, often with third-party old guard software that comes with it. We really feel like a serverless approach with SES is far more cost-effective, auto-scales to your requirements, and also takes care of this problem around why is the note not making it to my customer. So in terms of the recommendations, this is another thing that we're doing with most of these, with all of these communication services is providing a closed-loop mechanism. So a closed-loop mechanism as to how to improve why the traffic is not making it and how to improve the content that's being sent out. So Virtual Delivery Manager comes with clear recommendations on how to improve the reputation of your endpoint, how to improve the delivery rate of the emails that you're trying to send out. Coming back to the actual, for example, phone channel, we provide a similar level of APIs and insights into why our call's not making it out, what's your busy rate, what's your call capture rate, what's your handle times, and these metrics allow, again, for a kind of a closed loop, continuous improvement on ensuring that you are able to engage with your customer on the terms and in the way that the customer wants to be engaged with. So Virtual Delivery Manager launched at reInvent this year. It definitely focuses around that problem of ensuring that you reach a customer on their terms and that your message is making it into their inbox, which seems like a simple problem, but it's actually a super important problem for ensuring that you really close the loop on these workflows like orders or in the case of the USPS COVID test kits. So in terms of ISPs, this is another aspect that a lot of folks tend to forget about from a perspective of communication complexity. So with regards to SES, from an ISP and deliverability perspective, it's a two-party problem. It's not just a problem of how to get the note to the SMTP endpoint that a customer might have to basically get that into a particular inbox. ISPs also play a very important role in terms of basically ensuring what notes get to what customers. They have their own spam filters and their own mail relays, and it's important to understand how ISPs will behave and respond to the types of content that you're sending to it. So SES basically ensures that you have an ISP view, not just an enterprise view, as to how an ISP is either meddling with or helping ensure that your content makes it into a customer's inbox. So this ISP problem is also true across voice and video sessions. So we have similar metrics around ISP, video quality, for example, and how ISPs might be throttling voice or video sessions for collaboration or video banking use cases. So again, in these communication networks, you're dealing, and similarly on the SMS side, we have the same things with regards to SMS delivery through wholesalers. So in the communication networks problem, it's not just the enterprise, it's not just the customer, it's also all the intermediaries that are responsible for making sure that content makes it to a customer. And AWS, because of its position and where it sits in the network, it's able to provide that end-to-end visibility of what happens to that content, and ensuring that you understand why that content's either making it or not making it, and how you can improve the odds that you are able to reach the customer using the tools and services and devices that they want to use. So finally, communication developer services is, how do you learn about it? Well, we have a category page that's available on AWS, on the AWS website. This category page includes links to our GitHub blogs and solutions, such as the live call analytics solution that we were describing today for T-Mobile, information about Virtual Deliverability Manager that's available as part of SES. So I encourage you to obviously look at our GitHub repos and our solutions, and they all come with automated deployment scripts, so it's easy to deploy within your own account. Finally, we're also covered in the Gartner 2022 CPaaS Market Guide. and that where you can understand the broad set of capabilities, the modalities, and different transports that we support today as part of our communication developer services category in AWS. So with that, that's all, folks, and I'll be here for a few minutes and happy to answer any questions.